Welcome to the video series Transforming with SteepGraph, PLM ERP Integration Insights BOM Management, featuring Lars, Peder, Hanson, and Nyberg. Let's dive into today's topic. Key insights you will learn from this videos are: what makes BOM management between PLM and ERP systems complex and crucial? How do companies differentiate between EBOMs, engineering BOMs, and MBOMs, manufacturing BOMs? What are the differences between the traditional approach and the integrated approach for managing BOMs? What are the benefits of creating MBOMs in PLM instead of ERP? What challenges do companies face when MBOMs are created in PLM? How should companies decide whether to create MBOMs in PLM or ERP?
Welcome to another SteepGraph Tuesday video. This is Nyberg, your host, coming to you with another conversation with Lars Hanson to discuss the PLM to ERP integration. Okay, Lars, the topic today focuses on sharing and managing bills of material to ERP from PLM. Okay, so what are your thoughts on this topic? I know it's a big topic, so maybe we can see what we can get through today.
Yes, certainly, Chuck. It's a big topic, and as we discussed in our last video, even the question of just integrating simple things like properties and maybe documents and links between PLM and ERP is a big thing. But I guess what most companies are looking for as they're expecting this to give them some edge on their competition here is: how do we handle BOMs in this integrated world? How can we speed up things? How can we improve our quality when it comes to bills of materials? And for some companies that are new to PLM, there's a whole lot of new things to take into account there. I've seen companies that have been working with just a BOM without distinguishing between manufacturing bills of materials and engineering bills of materials and all the other types there are. If you count it, there's a lot of types of BOMs, but let's stick to EBOMs and MBOMs in this little discussion here. So for some companies, the advent of an EBOM is something that is new once they get a PLM system in-house. The traditional way of doing this, we could start there because there are many ways, as always. The traditional way of doing this is that when you work in your PLM system, typically with your CAD system, and you design your product and you evolve it, you more or less, without knowing it, or even without wanting it, create an EBOM, because, as I heard you say, Chuck, an EBOM is basically a list of parts where you say, these are the parts you need to create this product, to produce this product here. And that is created more or less by default as you work with your CAD system in a PLM system. I know it's not a finished EBOM as such, but the CAD BOM, as some people call it, is very close to the actual EBOM. Whereas the manufacturing BOMs, and we're talking the traditional way of doing it still, manufacturing BOMs, the MBOMs, are normally living in the ERP system. That's how many companies did it for decades, and that's how you do it most places today. And it makes good sense in many ways. And remember also that manufacturing BOMs, normally there's not just one. But many companies have several manufacturing sites with each their capabilities, their machinery that are different from one site to another, and thus you need a specific manufacturing BOM for a specific site. So how do we go about this? Now that we got a PLM system up and running and we have integrated the two, we know we can send data back and forth between them. How do we go about BOMs? In my world, there's two typical use cases. The first one is that you, in your brand new shiny PLM system, you create an EBOM via your CAD work, And then most PLM systems today have the capability to, from that EBOM, create an MBOM in the PLM system. And there are some pros and cons to this. The con is the biggest con I've seen is that the ERP system, or somewhere in the chain, you still need to add more information to this BOM before it is producible. Paint and oil are the classic examples. Design engineers normally don't worry about that, even though they design an engine that should be painted. So that there's more to it than just what the designers have been creating with their CAD systems. That's a con. The pro, when you do that inside of the PLM system, is the associativity. If you change something in your design, it will immediately reflect in the MBOM that is tied to it in the PLM system. So that was one use case. You use your PLM system to create your MBOM from your EBOM. The other use case is that, and that's what's going on in many companies, is that you create your engineering BOM, your EBOM in the PLM system with your CAD tools. You send that information over to the ERP system where the manufacturing BOMs, again in plural normally, are created. And there's some pros and cons to that also. I know, Chuck, that you've been working with the pros and cons of these two use cases. Maybe you could elaborate a little on what it's all about.
Yeah, because what I've seen, there's pros and cons, and what I've seen with two instances, like for example, if the MBOMs created in the PLM system, right? So the data quality is higher if it's created in the PLM system, because PLM really has control over what parts can and cannot be used, for example, right? So that control, it tends to be in the PLM system, the configuration control, versus in an ERP. Like you said, associativity. So it streamlines change management, for example, right? I just create a change management and both BOMs are updated automatically. And also it improves some collaboration, because now engineering can see what manufacturing is doing, right? Why aren't they using my new part, for example, or how are they're doing it? So to your point, but the con on that is, to your point too, is, hey, I need some more stuff that you guys don't have in PLM. The system, obviously, the system complexity increases because now it's trying to manage two BOMs with little effort, added effort. And manufacturing has to work in multiple systems, right? They're ERP and PLM now. So that's some of the cons that I've heard of and seen. Managing BOMs, the MBOM in ERP, again, the plus is manufacturing works in their own system. It gives them a heck of a lot more flexibility to do what they want. And it minimizes data being overwritten by PLM, right? Because a lot of times, if they start editing a BOM, right? Let's say they change quantity, and PLM gets revised, and that BOM gets revised, and they push it, all their effort just went out the door. They have to redo it all the time. The problem, though, becomes now you're duplicating effort because you're having to do things in two systems, data change, etc. There's a high chance of data inconsistency because it is flexible, so manufacturing can do whatever they want. And it also introduces kind of a silo, because now it's a black box in ERP to engineering, just like PLM is a black box for manufacturing because they can't see it. So it kind of introduces the silo effect as well. That's just what I've seen.
Right, interesting. Which leads me to, as you were saying, the overwrite thing. Is it your experience that versioning of BOMs is a common thing to do? Because that would be one way to go about the overwrite risk there.
Yeah, the versioning is still, you would have to figure out what changed, right? If you want to version the BOMs versus revisions. So usually it's a revision because it's a yes or no, black and white. I was Rev 1 one day, now I'm Rev 2 versus 1.1, 1.2. To me, versioning is 1.1, 2, 3, 4. How do you know which one to change? So it was just more black and white and obvious when just this revision first, this revision second. But but back into our previous conversation too, is take into effect what is pushed to an ERP, right? So that will also help determine what not to overwrite. So I may push a whole BOM for initial revision, but push only partial information, like we push make versus buy on things for the initial revision. But if I revise it, I don't push that anymore because that's really a manufacturing thing. So that's part of as people figure out what they want to do on the integration on data, that's something you think about as well to eliminate or reduce dramatically the chances of overwriting something.
Right. Oh, okay. Interesting there. Yeah. Another thing I was thinking about, or I've experienced with this, is that I said a moment ago, I know that as you work with your CAD system, you create the basics, at least for the EBOM. Now with ECAD, where you design electronics, that to me is a special use case, because in ECAD it's a very common practice to design your printed circuit board and to decide what components, transistors, capacitors, and so on, goes onto it. But you then deliver that information to production without the actual geometry of the components. You do not, as you normally would do in mechanical CAD, have your nuts and bolts and fasteners and things as a geometry. In ECAD, you often just put a reference number there, and that reference number often points to one of the component databases that are out there on the market, DigiKey, Mouser, those things. So that makes ECAD a little bit different. And one of the things I've seen go wrong there is that only one of the two systems working with this data actually has access to these databases. Because at some point in time, you need to figure out, okay, I need 14 of this resistor here. And so if you're working with ECAD, first of all, the PLM systems that we see today on the market are, in my view, and I'll probably take a lot of flack from the vendors here. In my view, they are still very mechanical CAD influenced. They're built on mechanical CAD, and the way they do things is always traceable back to mechanical construction. And ECAD is something, even though it's 2024 now, ECAD is still something that is a little out there on the side of things. So what I'm trying to say is, if you as a company work with both mechanical CAD and ECAD, be prepared to, when it comes to BOMs, be prepared to handle them a little bit differently, because CAD is not always what you think it is in this landscape here.
So it sounds like you're saying ECAD basically needs a lot more manual intervention to create its bill of material than.
That's what I've seen happening in the companies I've been working with over the years, that ECAD needs special attention here. Definitely, it's not as straightforward as MCAD.
Okay.
And I guess the other thing I would like to talk about here a little is the topic of overloaded BOMs, because it's very seldom that you as a company produce a product that has no variance. Normally, there is different variants of your product, and that is often handled by overloaded BOMs, 150% BOMs, 120%. But we must remember that in order to produce something, we must have a 100% strictly defined BOM. So how do we come from 150 or 120% BOM with the blue ones and the red ones in the same BOM, right? But production will say, okay, am I going to use the blue or the red one? You have to filter it down. So how are we handling this? Where should the filtering down to a 100% producible BOM takes place? This is, of course, pointing into the topic of configuration management, which we will cover in another video. But again, be aware when you set up your way of integrating your PLM and your ERP with regards to BOM. Where do you want this filtering to take place? I know, Chuck, you have some views on the best practice here.
It's just like I said. It depends. Also, I've seen them both where you had 150% BOM and filtered down, but I've also seen 100% BOM which were built from scratch, right? It was just built as is on the fly. I've seen that as well. And of course the ease, right? Like we talked about before. If I start out with an ERP system, I may be already able to do it in the ERP system because I use a third party to help me, as you talked about, or something, right? So now if I start introducing a PLM system, the question is, okay, can I just do the configuration in PLM versus the old way, having to shift? So those are a lot of questions they would have to answer. But in the end, manufacturing needs, for lack of a better word, 100%. What exactly am I going to build is really the goal here for what you're going to actually feed into the ERP system.
Yes. So again, there are many things to consider when you integrate your PLM and your ERP systems. I hope a little talk here has. I know it's not given all the answers, but maybe it's given some inspiration as to what should we consider. What are the important things that we need to know about before we start this whole integration journey here.
The other thing I'd like to add on this is because in the end, manufacturing is going to build whatever's in the ERP system. So we have to feed them as much information as possible. For example, like you talk about ECAD, right? So feeding reference designators that they may need. As in the bill of material, there's probably ones that need compliance, right? Do you have to have certain serialization or serial numbers involved? What else besides just parts, quantities, and fine numbers do you need to send? We talked about one thing is, okay, so now I have one part superseding another, right? So do they get that relationship? Because if they have a previous part, it's not scrapped, it's inventory. They're going to, and I send them part B, and because it superseded A, part A, they may just have part A inventory. So what tells them they're able to choose A? Again, same with substitutes. You know, they're the same. I give you B, you can use A. I don't care. Being able to have those relationship and that information in their system allows for flexibility too. Right, I can swap it out because in the end, once they start building it, it looked great today, but tomorrow they run out of stock or something, right? So they need to be able to understand, and get this information as soon as possible so they can change it on the fly. Because again, as we know, speed is of essence. So you need to think about what additional information does manufacturing need to be able to change on a dime, let alone to meet any regulations. What do they need to really complete this, to build this part?
Yes. So I guess that was it for this little video here. Closing remarks again from my side is try to get some quick wins also on the BOM area. You can't expect to do a big bang and everything is working from day one. You have to evolve your BOM integration, and the last things Chuck here said about the extra information you need to send, you have to build it up over time. But again, get some quick wins so that your management and your users can see that, hey, something is happening here. This is going to be good. If you can get that way of thinking into your company, you've come a long way.
I agree. Obviously, this isn't easy, but in the end, it is worth the effort because the efficiency, the speed in which you get this, it makes it well worth the effort. So,
Definitely.
Okay. Well, thank you, Lars, for the input.
Thank you.
For the conversation.
And again, we are here at SteepGraph. If you have any comments, any ideas, if you disagree with us, if you have questions that you want us to elaborate on, contact SteepGraph. We'll be there for you. And there will be more videos in the near future with other interesting PLM topics.
Okay. Thank you. Have a
thank
good
you.
one.
Summary of the video is integration complexity. Managing BOMs, bills of materials, between PLM and ERP systems is complex but crucial for operational efficiency. BOM types. Companies often struggle to manage EBOMs, engineering BOMs, in PLM and MBOMs, manufacturing BOMs and ERP separately. Traditional versus integrated approaches. Traditionally, MBOMs are created in ERP. Modern PLM systems now enable MBOM creation directly from EBOMs, enhancing data control and associativity. Pros of MBOMs in PLM: improved data quality, streamlined change management, and better collaboration between engineering and manufacturing. Cons: increases system complexity and requires manufacturing teams to operate across both PLM and ERP. Decision factors. Companies should assess the pros and cons to choose the right approach based on their specific integration needs and system capabilities. Get insights on PLM ERP integration from the experts. Have questions? Our team is here to help. Connect with us for personalized guidance or visit our website at www.steepgraph.com. You can also drop your queries at marketing@steepgraph.com. Let's simplify PLM ERP integration together.